The focus of this lesson is to understand the concept of digital currency and how digital currencies are used. You should also be able to understand the process of what the blockchain is and how it is used to track digital currency transactions. Now, digital currencies are becoming pretty common. When you pay for products and services using the internet, you will use a digital currency of some sort. A digital currency normally exists electronically. It's a method of payment that is similar to paying with coins and banknotes, which we're used to. However, rather than exchanging physical banknotes and coins to make the payment, the currency is exchanged digitally using computers. So we use things like credit cards, Apple Pay, digital wallets, all of those kind of things. We're also going to be looking at another type of digital currency, which is called a cryptocurrency, or the most commonly used cryptocurrency is quite clearly Bitcoin. And we're going to be looking at the technology that underpins that. So let's start with digital currency. Digital currency exists purely in a digital format. It has no physical form, unlike normal or fiat currency. Now, fiat is a Latin word which means let it be done. And since conventional currency is backed by governments and banks rather than being linked to gold or silver reserves, it is referred to as a fiat currency. In the old days, currencies were linked to gold reserves, or they were made of gold coins or silver coins or even bronze coins. So there was an actual metal that was passed as a currency. Nowadays, the banknote is just guaranteed by perhaps the government or a central bank, and that's why it's called fiat. Digital currencies are different from fiat currencies because they exist digitally. They're an accepted form of payment to pay for goods or services. They can be transferred between various accounts when carrying out transactions. And it's been made possible to bank online if you're using services like PayPal or kind of like a smartphone app, for example, Apple Pay, use of credit cards, use of fintech or financial technology apps like Revolut, perhaps, and digital wallets. All of those are possible. Now, money only exists as data on a computer system. There is nothing physical behind it. So it can be transferred just as physical cash has to be given to someone else. We can just transfer this data from your wallet to somebody else's wallet. Digital currency generally relies on a central banking system. Therefore, it is centralized. And this is a key term to use in the exam. Now, if you suppose Ira wants to send some money to Joey, Ira uses a particular bank, Bank X, and Joey uses Bank Y. So what will happen is that Bank X will use a central bank to transfer, or a central bank's regulations transfer the money to Bank Y. The problem with centralization is that maintaining confidentiality and security, they become a significant issue. Say if you don't want the bank or the central bank to know what's happening. Well, you can't avoid that with digital currency. The bank or the government will see everything. Now we can tie this up to cookies as well, because data about this payment, this digital currency, has to be kept encrypted to make sure it's safe. And the method of encryption used is using the HTTPS protocol, or Hypertext Transfer Protocol, secure. The payment details for a particular currency can be stored as a persistent cookie. That means that each time you visit a website to buy a product, your payment details are already entered and you don't need to type that again. Most of us will probably just activate or authorize it using a thumbprint or Apple ID or something like that. Other key points you need to remember for digital currency: well, it relies on a central banking system, it is centralized, and it exists electronically rather than physically. Now, one type of digital currency is known as cryptocurrency, which has essentially overcome these issues about confidentiality and security. A cryptocurrency, in essence, is decentralized. That means it's not controlled by a central government or a bank. There is no central authority. Payments are also encrypted using this particular type of currency. As there is no central authority managing this particular system of payments, therefore a different system which is based on blockchain is used to keep track of the payments. A blockchain is a method that is used to track all the transactions which are made using a particular cryptocurrency. Now, unlike existing digital currencies, cryptocurrency transactions are publicly available, and therefore all transactions can be tracked, and the amount of money in the system is monitored, and anyone who's connected to the network can monitor it. The transaction outline is very simple. If you remember the previous one, Ira wants to send some money to Joy. In this case, Ira's wallet will send money directly to Joy's wallet. There is no central bank that will monitor the particular transaction. So you have greater confidentiality. Of course, you might argue that the transaction is recorded on the blockchain and is publicly available, but it's also encrypted, and you're using digital signatures, which allow you a greater degree of security because you are not identifiable in the transaction. So if anybody's looking at that particular transaction, all they know is that this wallet sent money to that wallet. It doesn't know who the wallets belong to. It only knows that this much money was transferred. So let's look at blockchain in a bit more depth. Blockchain uses a decentralized database, also known as the digital ledger. All the transactions of network members of the blockchain are stored on this database. Essentially, the blockchain consists of a number of interconnected computers, but they're not connected to any central server. All transaction data is stored on all the computers in the blockchain network. Now, in a centralized system or a centralized digital currency, a central server like a bank will hold the transactional details, which is also not very safe because all you need to do is hack the central server and you can alter the transaction record. Now, in a blockchain network, because a copy of the ledger is on every single computer, to effectively conduct a similar attack, you will need to take over more than 50% of the network, which is very difficult. So if you had 1 million computers in the network, you would have to take over more than 500,000, and that's very difficult. So blockchain tends to be a lot more secure because whenever a new transaction takes place, all the network computers get a copy of the transaction. Therefore, it can't be changed without the consent of all the network members. This effectively removes the risk of security issues such as hacking in a blockchain. Now, blockchain is used in many areas these days, such as cryptocurrencies, smart contracts, politics, and even education, especially the issuing of degrees and certificates. So how does a blockchain actually work? Whenever a new transaction takes place, a new block is created on the blockchain. And this block has the data, for example, the name of the sender and the recipient, the amount of money or whatever else you want to store on it. It has a hash value, which is a unique value generated by an algorithm. And this is usually a cryptographic or encryption algorithm, such as SHA-256, which acts as a fingerprint. So all that data is put through this hashing algorithm and then mashed up to create this new hash value, which is unique to the block. The block also has the previous hash value, which points back to the previous block in the chain. Now, these hash values cannot be reversed engineered. They are very unique because they are one-way systems. So you put the data in, you get this hash value. If you alter the data, you get a new hash value, and you can't reverse engineer it. A new hash value is created each time a new block is created, and this hash value is unique to each block and includes a timestamp which identifies when an event actually took place. So if you look at the diagram on screen, you can see that the first block value has a hash of A4BF, and the previous hash was 0000. So this is in effect a genesis block. Now the second block also has the previous hash value A4BF, which allows it to link to the previous block. And this process continues on and on and on. And every time you add a new block, for example, if we add block 6, previous hash will be AA00 and the new hash value will. So the first block is known as the genesis block since it doesn't point to any previous block. The previous hash value is zeros because there's nothing before it. Now let's look at the security implications. Suppose block 2 is changed in some way. Any changes to the data within block 2 will cause the value of the hash to change. It will no longer have the value 6AB1. So we change the data and the new hash value becomes 7D43. Now you can see the problem here. The moment the hash is changed, it means that block 3 and beyond will now become invalid since the chain was broken between block 2 and block 3 because the previous hash is no longer valid because we got a new hash. Now that broken link means that it's very difficult for you to justify a hack in the middle of a blockchain or anywhere in the blockchain because the hashes will all turn up different. This prevents tampering because then the hacker will need to recreate all the other blocks in the chain and generate new hashes. And even if the hacker does that, has an entire new blockchain made up, that's going to be different from every other blockchain that's on the network. So there will be the concept of consensus. Only the hacker will have this new blockchain. Everyone else, 999,999 computers on the million-strong blockchain network will have a different chain. So the hacker has another problem that this has to be injected in over 50% of the computers, which is very difficult. Another thing that prevents this type of attack is called the proof of work, which makes sure that it takes 10 minutes to determine the necessary proof of work for each block before it can be added to the chain. And this is policed by miners, which are special network users that get a commission for each new block that's created. So the miners will police the network to make sure that nobody's messing around with the proof of work, which you can't add immediately and requires up to 10 minutes to determine that it's been calculated correctly. The whole process of creating new blocks is slowed down, which foils hackers and also means that the currency is regulated by all the network users rather than a select few. Now, in the exam, chances are that you're not going to be asked about miners or proof of work. All of this part is just for your knowledge. Another element that's useful in a blockchain is the concept of hashing. Hashing makes it impossible to hack into the blockchain since it would be necessary to attack every single block in the chain at the same time. So it only takes one block to break the link for any transaction to be terminated. When a new block is created, it is sent to each computer in the blockchain and it's checked for correctness by each computer before being added to the blockchain. And if a new network user is created, they get a copy of everything in the whole blockchain system. So nobody can manipulate the system for their own benefit. So everyone gets a copy, everybody checks everything. Okay, that's all for this particular lesson. Hopefully you can answer the following questions. You should be able to give two differences between digital currency and cryptocurrency. You should be able to explain what is meant by proof of work, what is meant by a hash value, how does a blockchain work, how does a blockchain prevent tampering, and what is meant by a digital ledger. If you are struggling with any of these questions, please go through the video again. Otherwise, post your question in the comments and I'll get back to you. That's all for now. I'll see you in the next one.